Hello, everyone. It's a great pleasure for me to be able to join you virtually today to talk about the International Association of Geodesy. If you don't know me, I'm Richard Gross. I work at NASA's Jet Propulsion Laboratory, where I've done research into understanding changes in the Earth's rotation, gravity field, and now determining reference frames. I'm also the current president of the IAG. So let me start with basics. Geodesy is the science of accurately measuring and understanding three fundamental properties of the Earth and how they change in time, namely the shape of the Earth, the rotation of the Earth, and the gravity field of the Earth. Central to all of this is determining and disseminating the terrestrial reference frame. So the International Association of Geodesy is that professional society that is charged with advancing geodesy. The IAG is 163 years old this year. We can trace the origins of the IAG back to 1862, when some countries in Central Europe wanted to determine anomalies in the Earth's curvature, what's causing the deflection of the vertical and the relative structure of the geoid. And not only were they concerned with observing these anomalies, but they wanted to understand them. So they wanted to interpret the observations in terms of the structure and composition of the Earth. So the first conference of the representatives from the states who were looking at the anomalies in Central Europe was held in Berlin in 1864. And at that time, they created a permanent commission, a central bureau, and decided to hold general conferences, meetings, every 3 years. And so those general conferences are considered to be the forerunners of the IAG and IUGG General Assemblies. So the International Geodetic Association was established at the General Conference in Berlin in 1886, and the first president was General Carlos Ibáñez del Bierro from Aegean in Spain. When the International Union of Geodesy and Geophysics was established in 1919 by the International Research Council, which today is known as the International Science Council, the International Geodetic Association joined the IUGG and changed its name to the International Association of Geodesy. So the IAG is one of 8 of the associations of the IUGG, and it has a number of unique properties. First, having to do with the number of services that are affiliated with the IAG. So like I say, from the very beginning, not only was it important to observe the geodetic properties of the Earth, but we wanted to understand what's causing changes in those properties. And so the observations are coordinated by the various services of the IAG, and the scientific understanding is done by the various commissions of the IAG. In addition to the large number of services the IAG has, 12 of them, the IAG also established its global geodetic observing system. And it's the only association within the IUGG that has established an observing system. There are other global observing systems, like the Global Climate Observing System or the Global Ocean Observing System, but within the IUGG, the IAG is the only one that has its observing system, the Global Geodetic Observing System. So this slide shows the organizational structure of the IAG. Like I said, the scientific activities of the IAG are handled in the 4 commissions and the intercommission committees. We also have a communication and outreach branch, and of course I mentioned the Global Geodetic Observing System with its services. The governance structure of the IAG consists of the IAG Council, which sets the strategy and elects the executive committee and bureau members. The council is made up of representatives of the member countries of the IAG. So there's also an executive committee that implements the strategy of the council, and the bureau, which consists of the president, vice president, and secretary general, and it coordinates the just day-to-day activities of the IAG. So, as I said, the scientific activities of the IAG are done within its commissions, and in particular within the working groups of the commissions. And there are 4 commissions. The first is on reference frames. The second is on gravity field of the Earth. The third is on Earth rotation and geodynamics. And the fourth is on positioning and applications. In addition to the commissions, we also have intercommission committees and projects. So an intercommission committee is an activity that spans more than one commission. So for example, the Intercommission Committee on Theory is concerned with the theory of the Earth's gravity field, of the Earth's rotation, of determining reference frames, for example, and its mission is to advance geodetic theory. There's also an Intercommission Committee on Geodesy for Climate Research that is advancing the use of geodetic observations for climate research. We have a third Intercommission Committee on Marine Geodesy that wants to advance the theory and applications of marine geodesy. At the last IAG Executive Committee, it was decided to go ahead and establish a 4th Intercommission Committee on Planetary Geodesy. This is currently being established, and by the IUGG in 2027, we should be able to approve it as a full component of the IAG. In addition to these intercommission committees, we also have a project on novel sensors and quantum technology for geodesy. And this is, to advance quantum technology and novel measurement concepts for geodetic applications, such as quantum gravimetry, using atom interferometry for measuring gravity on the ground and in space, or novel technology like laser interferometric ranging between test masses in space, or relativistic geodesy, so comparing the frequencies at which clocks tick at different heights in the gravitational field. So in addition to the commissions and intercommission committees, which are concerned with the scientific understanding of the geodetic properties of the Earth, the IAG also has services that coordinate the observations of the geodetic properties of the Earth. And we have 12 services, 6 of them concerned with geometry and general services, and 6 are concerned with the gravity field of the Earth. In addition to those observational services, we also have the Global Geodetic Observing System. So GEODESY was established in 2003 as an IAG project and became a full component of the IAG in 2007. And it is meant to be the observing system of the IAG. It's meant to organize the technique-specific services under one unifying umbrella, under one global geodetic observing system, if you will, in order to form a comprehensive geodetic observing instrument, and is meant to integrate all of the separate pillars of geodesy, the shape, the rotation, and the gravity of the Earth, into one consistent observing system. So I'm not going to say too much more about GEODESY because Laura Sanchez will be talking about it later today. So probably the best known activity of the IAG are its services, and in particular, the International GNSS service. So this is a map of the stations that contribute to the activities of the GNSS service, determining the positions of these stations, Earth orientation parameters, for example. And there are over 500 stations that contribute to the IGS. In addition to the IGS, there's also the International Laser Ranging Service, the International VLBI Service for Geodesy and Astrometry, and the International DORA Service. These are the four main geometric techniques that provide data that is used to determine the International Terrestrial Reference Frame. So a TRF is an accurate, stable set of positions and velocities of reference points on the Earth's surface. The TRF provides the stable coordinate system that allows us to link measurements over space and time for numerous scientific and societal applications, including critical climate and sea level change studies. The TRFs are determined by networks of the observing systems, GNSS, VLBI, SLR, and DORIS, along with ground surveys of stations that are co-located at sites. And by co-locating stations from the different techniques at the same site, it helps tie the networks of the different techniques to each other. So not only do these stations provide the data for determining the TRF, but also for numerous direct science investigations. So for scientific applications, the TRF and improved TRFs is needed for many reasons, including critical climate and sea level change studies, as I said earlier. And so GEGOS, a number of years ago, set a goal for the TRF to have an accuracy better than a millimeter and to be stable to better than 1/10 of a millimeter per year over a decade. So the international standard TRF is the ITRF, the International Terrestrial Reference Frame. It is determined under the auspices of the International Earth Rotation and Reference System Service, and I won't say too much more about it because Zuhair Al-Tamimi will be talking about this later today. I will just show a map of the stations of the latest determination of the ITRF, ITRF 2020. The red dots are the GNSS stations that contributed data to the ITRF 2020. Blue circles are the DORA stations, and in green are the satellite laser ranging stations, and the gold stars are the VLBI stations. So besides the International Terrestrial Reference Frame, the IAG provides numerous other geodetic data and products. And these observations are taken not only from ground-based instruments, but also airborne and space-based instruments. If you go to the GEGOS website, you can find a list of all of the geodetic products produced by the IAG. So reference frames, not only the terrestrial reference frame, but also a height reference frame, and a celestial reference frame, and a gravity reference frame. Earth orientation parameters, of course. We determine the models of the surface deformation of the Earth, models of the ocean topography, how the sea level is changing, digital elevation models of the surface of the Earth, ice sheet and glacier variations, station positions and their variations, tide gauge records, and sea surface heights, of course. And similarly for the gravity field, we have global gravity models and their temporal variations. We have gravity measurements on the surface of the Earth at points. We determine regional local geoid models, ice sheet and glacier variations, and height systems. And just a few of the positioning and applications are to understand the thermosphere, the ionosphere, the lower neutral atmosphere, a number of other atmospheric products, and GNSS satellite orbits and clocks. And not just the GNSS satellites. The geodetic techniques are used to precisely determine the orbits of numerous Earth orbiting satellites. So geodetic data and products have numerous applications, not just within the geodetic community, but within the science community at large. So I've listed a few examples here. For example, numerical weather prediction models simulate radial occultation measurements, as well as zenith total delay and integrated water vapor measurements that are taken by GNSS, for example. We can estimate or infer changes in groundwater by looking at the deformation of the surface of the Earth as observed by GNSS or INSAR, as well as by changes in the gravity, which tells you changes in mass, for example, as taken by the GRACE gravity satellites. We also can better understand sea level changes, the absolute change in sea level as measured from the center of the Earth by GNSS or SLR or DORS tracking of radar altimetric satellites, as well as relative sea level changes, changes in sea level relative to the surface of the Earth as measured by GNSS measurements of land height change that are, with stations co-located with tide gauges. We also estimate changes in the height of ice sheets and glaciers by using GNSS and SLR to precisely determine the orbits of the laser altimetric satellites. And we can also infer this from the satellites measuring the gravity of the Earth, like GRACE and GRACE Follow-On. And of course, then, there's numerous applications to geohazards, earthquakes or volcanoes, by measuring the crustal deformation of the Earth from GNSS station displacements and INSAR. And we are even developing the capability to operationally augment tsunami early warning systems with GNSS measurements. So in addition to its scientific applications, there's a whole host of societal applications. In the first row here, I list some of the Earth observations of gravity, sea level, oceanography, earthquakes, volcanoes, the cryosphere, or tsunamis that can be studied with geodetic observing techniques. And in the second row are the space missions that provide this data, GRACE and GRACE Follow-On, Sentinel-6, laser altimetric sea surface height measurements, as well as SWOT, NISAR, a new satellite that will be launched later this month, hopefully, to study the deformation of the land surface of the Earth, and of course ISAT, which studies changes in the height of ice sheets. But this geodetic infrastructure has wide uses for society. Everything from precision farming to autonomous navigation of drones or automobiles to, determining the terrestrial reference frame, which supports any kind of positioning and navigation or location service used for any purpose, including locating the restaurant you want to go to with your cell phone. And it's even used in financial transactions because of the GPS-based timing signals. So I just want to close with one other important aspect that the IAG does, and that is to engage with the larger scientific and societal community. So I just want to highlight one of the many organizations that the IAG is working with to advance geodesy. And this is the United Nations Global Geodetic Center of Excellence. So about 10 years ago, the United Nations General Assembly passed a resolution about the importance of the global geodetic reference frame to science and society. A few years ago, the United Nations established the Global Geodetic Center of Excellence at the United Nations campus in Bonn, Germany, with the overarching goal of assisting the United Nations member states and geodetic organizations like the IAG to coordinate, collaborate, to sustain, enhance, access, and utilize an accurate, accessible, and sustainable global geodetic reference frame to support science, society, and global development for the betterment of the people, of the planet, for peace and prosperity. So pretty lofty, but the sole focus of this Center of Excellence at the moment is on improving the terrestrial reference frame. And so in the last few years, the Center of Excellence has been quite active. It has conducted what they call listening tours, where they have surveyed the users of geodetic data and products, and in particular the reference frame, to better understand what the user community needs from geodesy. And they talked to over 500 people as part of this listening tour, and the results of what they heard was documented in this Global Geodesy Needs Assessment Report published by the Global Geodetic Center of Excellence. They also published a document on the hidden risk of relying on a reference frame that has too many single sources of failure. And it's not just the scientific reliance on this, it's the society's reliance on this. And there are risks, in relying on a fragile reference frame. And so the third document that the Center of Excellence has produced so far is a first joint development plan for global geodesy that lays out steps that member states and geodetic organizations like the IAG can take in order to make the reference frame more robust and more reliable and more sustainable in the future. Currently, the Center of Excellence is assessing the maturity of every step that is taken to determine the global geodetic reference frame. And by assigning different maturity levels to each step, this will allow the Center of Excellence to assess where the resources are most needed in order to make the reference frame more robust. So that now brings me to the end of my presentation. I've tried to give an overview of the IAG and its data and products and how they're used by science and society, highlighting the importance of the International Terrestrial Reference Frame that the IERS produces. More information about the IAG can be obtained from its website. The URL I showed there at the bottom right appears to be obscured by my photo, but if you just Google IAG Geodesy, you'll find this website. If you'd like to be involved, become involved in the IAG if you're not already, please don't hesitate to contact me, and I'll be happy to provide you with information about how to do this. So thank you very much, and I will be happy to take questions. Thanks. Goodbye.